Now let's look at an example from your textbook. Here we have a random sample of 14 stores, and our problem is the business objective is to forecast annual sales for all the stores based on the number of profiled customers who live no more than 30 minutes from the store. So to forecast annual sales for individual stores, you have taken a random sample of 14 stores, and for each of those stores we look at the annual sales from the previous year, okay, and the corresponding number of profiled customers living within 30 minutes of the store. Okay, let's go to Excel and do the further computations. So here is the sample data. So first thing to do is to define the dependent variable and the independent variable. So the dependent variable is the variable whose value we want to predict. In this example, we want to predict what the future annual sales will be, okay, given a estimated number of customers living within 30 minutes of the store. So the number of customers living within 30 minutes of the store is given value. You already know that, and we want to, based on that, we want to predict the value of sales. So sales is your dependent variable. Y is sales, annual sales in millions, and independent variable X is the number of customers living within 30 minutes. It's very important, extremely important to identify Y and X correctly. If you identify X and Y in the reverse way, all your computations will be wrong, and and therefore it is extremely important that this first step is correctly done. Now, to see whether there is a relationship that can be estimated using the linear regression line, we can plot a scatter plot. Scatter plot is you plot the Y values in the Y axis, the X values on the X axis. So here customers is X and sales is Y. Okay. Now in Excel, if the X value and the Y value are adjacent, if the Y value is to the right, then we can highlight both the columns at the same time and then insert a scatter plot like that. Okay. But if the Y value is in the first column and X value is in the second column, then this won't work, because then it will put the X value on the Y axis and the Y value on the X axis. So if that is the case, then you have to first plot just the Y, put it in the Y axis, and then edit the data values and insert the X values through that way. So that way you can make sure that X values go into X axis, Y values go into Y axis. In our case, since Y is to the right of X, you don't have to do the two-step process. You can go straight to the scatter plot. Okay, so like that. Now move the plot and then format it. Okay, so this is annual sales. Okay. You must, whenever you prepare a graph, you must properly format the graph. So here let's include axis titles. Okay, X-axis title is profiled customers. Profiled customers are the ones who live within 30 minutes. Again, this is in millions. And Y-axis is annual sales. $1 million. Okay, and we can see that there is a well pronounced linear relationship between X and Y. So pursuing a linear regression approach is a valid one. Okay. So now let's apply the formulas that we saw from the previous video and determine the value of b sub 0 and b sub 1. So we want an equation like y-intercept plus slope times x based on these x and y values, and for that we need these two columns, and we need the y-squared column for computing some sum of squares which we will use later on. For the purpose of estimating b sub 0 and b sub 1, we need these two columns.